This is TechSNAP, episode 396. Hello and welcome to TechSNAP, Jupiter Broadcasting's Systems, Network, and Administration podcast. This episode was recorded on January 30th, 2019. My name is Wes, and I'm joined by Jim. Hello, Jim.
Hi, everybody.
Welcome back. Boy, we have a lot to talk about today. So one of the things we've spent a lot of time talking off-air about is ZFS, and we haven't yet had time to really dive into that. We've been too busy talking about all the other interesting things going on, but there have been several recent developments we just couldn't not comment on.
Yeah, the big thing, if you're deep into the ZFS ecosystem like I am, everybody's been talking about the breakage coming up with the Linux 5.0 kernel. The developers they've enforced deprecation of a kernel symbol that OpenZFS on Linux relied on, and we're going to talk about whether that's as big a deal as it's been made out to be or not.
What made this whole thing worse is just before all this happened, back in December, there was some interesting news, some recognition from the OpenZFS community that a lot of new development was happening over in the ZFS on Linux tree. So FreeBSD in particular was thinking about rebasing, moving things over, and using the ZOL tree as sort of the origin for everything. So it was kind of a great time to be a ZFS user on Linux. And suddenly, more breakage, more reminders that for a lot of people, the ZFS just doesn't feel at home in Linux.
Yeah, but to be fair, though, nothing has actually broken. This is something that we're talking about. It's an issue that doesn't impact anybody until the 5.0 kernel, which absolutely nobody is using in production at this point. That is some severely bleeding edge stuff. It's probably not going to make it into, even like in the Ubuntu world, you're probably not going to see that even in the intermediate releases for another year or so, much less the long-term service releases.
Unless you're compiling your own kernel and therefore also your own ZFS module, you're not going to hit any problems.
Yeah. And if you're doing that, you've got enough broken things already to worry about. This is not really going to make a noticeable bump in the road for you. I want to mention also, about FreeBSD being rebased off of ZFS on Linux and the other OpenZFS branches. That's not just something that's going to happen. It's actually that's something that's already in the process of happening, and it's pretty cool stuff. Some people have kind of gotten their noses out of joint about it, but notably, not so much the actual developers themselves. FreeBSD is not by any means going to be some kind of second-class citizen. They are actually going to have their own tree in the ZFS on Linux repository. So everybody is playing together really nicely. It's pretty exciting stuff.
We're going to dive into that, and there's a lot more to talk about. Before we do, just a little bit of network news. You've probably already heard this, but if not, Jupiter Broadcasting has a brand new show. That's right, Choose Linux. The show that captures the excitement of being new to Linux, to exploring that world. Now, you might already be old hat, but we've all been there. We've seen the excitement about all this stuff is free. It's open source. I can just use it. I don't have to pay for it. I don't have to go download it from some sketchy website. It's already on my computer. Well, if you are interested in that feeling and recapturing it, go check out chooselinux.show. It's got Joe Ressington, our wonderful editor and host of so many great shows, including Late Night Linux and Linux Action News. And it's got Jason. You may have seen some of his work over at Forbes. He's also running the Elementary OS Challenge. So lots of good stuff to check out. The other thing you should be aware of, the upcoming Linux Fest Northwest Conference. It's their 20th anniversary, and JB is trying to make it a blowout. I'll be there. And Jim, it sounds like you'll be there too.
Absolutely. I will be there. I'm very much looking forward to it. I've never been to a Linux Fest Northwest yet.
It's going to be a great one to go. We're going to have a whole big barbecue. People are going to give talks. Alan Jude, formerly of the TechSNAP program, he's going to be there. He's going to be giving an OpenZFS talk, actually, so you don't want to miss that. Plus, Joe's coming. We'll have Popey and Wimpy joining. It sounds like all kinds of your favorite people from JB. Come join us. Come shake some hands and enjoy all the Linux. All right. With that out of the way, Jim, you and I were talking, and we just couldn't let it stand. There was so much misunderstanding, so much misinformation going around. We wanted to use our little platform here to try to set the matter straight.
Yeah, absolutely. When the news came out that the Linux 5.0 kernel was going to deprecate the symbol that allowed ZFS to do vectorized SIMD calculations, And what that basically means is being able to natively access the floating point unit registers. When that announcement got made, a lot of people went into severe Chicken Little mode. The sky is falling. ZFS is going to take a huge performance hit. Nothing will ever be the same. But luckily, that's not actually the case.
The network has touched on some of these issues before. In particular, I'll point you to linuxunplugged.com/284. We interviewed Neil Gompa, and he shed light on a lot of these same topics. BSD Now, of course, also touched on this, especially the future of the implementation on FreeBSD. You can find that in episode 279, The Future of ZFS. I'll also note that Richard has been a previous guest on the BSD Now show, episode 157, ZFS, the Universal File System. We're lucky to be joined by him once again to hopefully answer all these questions and make us feel a little bit better about using ZFS on Linux. Hello, Richard, and thank you for joining us. There's been all kinds of news, and we're really glad to have someone a little close and who spent a long time in the trenches working on ZFS to provide some insights.
It's great to have you here. I want to talk about some of this ZFS and Linux 5.0 and a little bit of drama that we've had with Greg KH recently.
Before we get started with that, maybe, Richard, you could just give us a little bit of background about your experience in the ZFS world and your experience in general.
It's actually funny because I wouldn't have been involved with ZFS at all if it hadn't been for Windows 7. Actually, not just Windows 7, but also a Seagate hard drive. As I set up a media center system in 2010, it failed, and the recordings were on the drive that failed, which was drive D, and Windows just refused to boot. And after that, I was just like, there has to be a better way. And I didn't want to trust Windows for storage anymore, so I was looking for ways to virtualize it and do storage on Linux. Now, I tried MD-RAID, LVM, ext4, or XFS, and at the time, no matter what I did, I would only get 20 megabytes per second region writes sequentially, which isn't very great for doing video recording and video streaming.
Wow. You really tried basically all the other options.
Yeah, well, I had 6 drives with RAID 6, so at the time I had no idea why. I actually heard of someone having a problem similar not that long ago. I'm not really sure what the issue is there, but eventually I heard about ZFS on Linux, and I tried it out. I got 210 megabytes per second throughput, but give or take 10 megabytes per second. And I was like, I can work with this, but there are some issues. I can fix these though. So I spent some time fixing them. And then after they were fixed, I just kept working on it because there were other neat enhancements I wanted to try. Then I got involved with doing consulting work for it. I got a job at Cluster HQ and later Profit Store and so on. So yeah, that's basically how I got involved with ZFS, and we can thank a Seagate hard drive and Microsoft Windows 7 for handling the failure horribly for that happening.
Yeah, I've had my lunch eaten by file systems and disks way too frequently. I first got into ZFS way back in the early days when it first dropped with FreeBSD 7.0 release. I wasn't that interested initially, new file system, whatever. But, I read some of Jeff Bonwick's posts, including one where he hadn't realized that he had a failing disk in a system until he just happened to do a zpool status and saw that he had more than 10,000 checksum errors, but no lost data. And I saw that and I was like, okay, yes, I need that. And, I was looking at the tech specs of ZFS and how it individually checksummed every block it wrote and, checked the checksum every time it read or, generated a new one every time it wrote. And I thought, okay, well, clearly this is going to be dog slow. The question is, will it be fast enough that I can live with it? And then greatly to my surprise, it turned out not to be any slower than what I had been doing before, which was UFS2 on FreeBSD at all. So I was like, well, I really don't have any downsides here, and just kind of grew into it over, more than a decade since then.
These days, basically all of my systems, aside from the ones where I actually just can't do it, like, say, an iPhone, use ZFS as a root file system. Basically, if I can put ZFS on it, I do. even if it might not necessarily make that much sense, like my cousin's laptop, for instance, that he wanted to use Linux on. I gave him Ubuntu and I did a ZFS rootfs, which took longer to set up because it's not integrated into the graphical installer, but boy, was it worth it.
Yeah, that kind of makes me curious there, Richard. What do you primarily use ZFS on Linux? Have you dabbled in some of the implementations on other operating systems? Because that's one of the things about ZFS that makes it so great. There's a lot of those, but being able to use it on multiple operating systems with the same file system and by and large, not always everything, but by and large the same features, that's huge.
Yes, so I don't use it that much on other systems. I have a pfSense router, which is, of course, FreeBSD11, and it has a ZFS root file system, of course. And I've done a few minor things there, but I really don't. It just is set and forget it for me on those environments.
Yeah, let's talk about the vectorized SIMD stuff. What we're losing with the kernel, the kernel symbol that's been deprecated.
This actually isn't really that big of a deal. There have been compatibility breaks for years, as the kernel API is unstable. If something in the kernel isn't using it, they just remove it. And they really don't care about any external users. This isn't news, unfortunately. But a symbol that people have been somewhat upset about is one that is used to basically make it safe to do floating point and vector operations inside of the kernel. And unfortunately, not many people actually understand how this works very well. So from their perspective, which is perfectly understandable, removing the symbol basically breaks ZFS's acceleration code, which has been in it since 0.7, at least on Linux. However, in actuality, that symbol really is only, well, the two symbols. One is to turn it on, one to turn it off. They really only do two things each, one to do it and the other to reverse it. So one thing that it does is it turns off kernel preemption.
Talk to us about what kernel preemption means, please, Richard.
I guess I have to go back to DOS for this. So in the DOS days, computers really only did one thing at a time. You had to stop your application in order to do something else. Then you had these window managers that were actually able to sort of do multiple applications, but what they were doing was they were waiting for one application to say, okay, I'm done, give it to someone else, and then another one would say, okay, I'm done, give it to someone else. And if one actually didn't relinquish the CPU, things would basically freeze, which happened a lot in the DOS days and into Windows 9X as well.
So when you talk about kernel preemption, you're talking about the difference between cooperative multitasking and preemptive multitasking. The kernel preemption is what makes the multitasking possible, right?
Well, I'm getting there. So cooperative is one way of doing things. And as if an application is misbehaving, then it takes out the entire system. With preemptive multitasking, you don't wait for the application to say, okay, I'm done. The kernel is basically checking on an interval, being like, is it something new to do? Is it something new to do? Is it something new to do? And if it's something new to do, then the current application gets booted off and is told to get on the end of the line. Preemptive multitasking has also been moved into the kernel as well, where the kernel will preempt itself. However, for certain things, this isn't desirable because of how things have been designed in terms of registers, where it assumes for the sake of, or traditionally assumes for the sake of faster context switching between itself and applications or between applications, that unless it's been touched in a certain way, the registers are basically haven't been touched and they're all zeroed, for instance. So if we are touching the register to do SIMD acceleration and we get preempted and moved somewhere else, then that user space application now has access to, well, if we're doing encryption, potentially encryption information, or whatever it was doing just isn't there anymore and it crashes. There's a symbol you can use to do two things. One, it said it will turn off preemption. And two, it will save the state by using a certain CPU instruction, which these days is on x86 or AMD 64, xsave op. And by doing that, which it's saved in a task struct if I recall, although that might have changed recently. But in doing that, it's now safe for the kernel code to use SIMD acceleration, for instance. And then after it's finished doing that, it will have an inverse symbol that is called, that basically does the reverse. So it puts the contents of the registers back to how they were. And then it turns preemption back on. As when you turn preemption off, you go back to cooperative multitasking, which is, I guess, the days of Windows 9X, basically.
Or Mac OS Classic.
Yes, that too. That's the other famous example. So what we really are losing is that symbol, which is just a wrapper for these two things. Now, kernel preemption, there's something in the header we can use for it. I believe it's just setting a flag to turn it off inside the task struct, so we don't even need a symbol for it. And saving the register state, we don't need a symbol for that because it's just a CPU instruction. So it's very easy to make our own. The reason we didn't was because it has a maintenance burden. You have to take into account, okay, what if a new CPU comes out? Is the existing code going to, well, what if a new CPU with new ISA instructions coming out? Is the existing code going to work there? If you build it on a system that has SIMD support, is it going to work on one that doesn't? If you build it on one that doesn't, is it going to work on one that does? If certain runtime conditions happen, are those going to be handled properly? And it's just a headache that we could avoid by using the symbols that the kernel provided. Now, what the kernel did was that they actually decided to add locking to the symbols. So they made new symbols that wrapped those, and then switched everything to the locking. And now I actually haven't looked to see exactly what the locking does for one reason, which is that I'm not entirely sure if I want to. Well, I've been thinking of implementing that code in ZFS on Linux myself, and I was thinking, do I want to have looked at this before I've done it? Because there are some people at mainline who we can get into later who haven't been all that present about things, and I was like, maybe I could just not look at it and tell them basically I didn't see any of their code, so don't complain to me. The only reason that they would have that lock there is because of data structure manipulation. So they probably changed how things are being handled there, and now they're doing memory allocations and adding to a linked list, which would handle another edge case that I don't believe was being handled previously. By doing that, they would need the lock. After they did that, they were like, well, the original symbol that wasn't marked GPL isn't needed anymore, so let's just remove it. And a lot of people got upset about this because they were like, in their mind, they just changed the symbol from one to another, even though that wasn't exactly true. And I believe that was some of the things on the mailing list were just because of the order of events. People at mainline didn't have quite the same view as other people that were a little upset by this. However, I think to cut to the chase here, in reality, this is probably a blessing in disguise, because the way that mainline was doing this was saving registers that we didn't need to save. If we're doing AVX acceleration, we don't need to save the SSC2 and x87 registers as well. Or if there's also the AVX 512 registers, and we don't need to save them if we're not using those registers. So we actually could make the code slightly faster if we were to implement our own. The downside is that it's a bit of a maintenance headache, as I said, as now we're doing a bunch of stuff on our own that we didn't have to do previously. The improvement in performance is probably going to be 1% or less. And it's just not something I would traditionally deem worthwhile to do. But since we're being forced to do it, why not? So if I look at this like I've been mulling it over, I probably will end up doing the faster implementation simply because I can, and I've been forced to do it by mainline.
Because the alternative is these would all be slowed down, right? Like if you didn't take advantage of the vectorized instructions, then computing those checksums would be slower.
If we're CPU bound. If we're not CPU bound, no.
Right. So is that enough? Like you were just kind of touching on that. Is that enough incentive to get this work done? How difficult is it? And I'm curious too, because you were talking a little bit about the maintenance burden, and that's a huge thing, especially since ZFS is multi-architecture on multiple operating systems and targets. So having more and more things to tweak just makes, there's these informal lists of when you're making changes in PRs, you got to know to check for all of these different problems.
Well, I'm not that concerned about the other OpenZFS platforms. I don't think this really affects them, and I will keep them in mind while I'm making these changes, especially since FreeBSD is adopting or will be basing on ZFS on Linux to make it the upstream repository from which it will be sending and receiving patches. So, yeah, I believe Matt Macy's working on that. So, and I actually spent some time giving him some tips on issues he was having in adapting the ZFS on Linux code to FreeBSD. And the last thing I'd want to do is make more work for him, because then he'll ping me and ask me about how to fix it, and I'll be making more work for me.
What do you think the performance impact is going to be like for anybody who ends up needing to run a build that doesn't have the vectorized SIMD before the code to do it inside the ZFS kernel module comes out?
It depends on whether or not the CPU bounds before and after, and also whether or not they're using the SSC 2 or AVX acceleration. I don't actually have numbers for that offhand, so I couldn't tell you. I'd say at least just a ballpark range would be at least a factor of 2 slowdown if you're already CPU bound.
Sure. I guess really the question is more along the lines of, what kind of CPU usage amplification factor would you be expecting over using the vectorized code versus using non-vectorized? Put it this way, I usually see very negligible CPU impact on my systems from running ZFS. And if you double very negligible, you're still not really looking at a whole lot of impact.
I'd rather just say I'm not 100% certain than give an incorrect answer.
Fair enough.
However, I will say this. It would take me between 3 to 6 hours, depending on how careful I'm being, to implement a fix for this. So it really isn't a big deal.
I've got a follow-up question. So this was kind of a storm in a bottle. We also saw some attitudes expressed by various Linux kernel maintainers about not being especially sympathetic towards ZFS on Linux. And as you mentioned, Richard, there's recently been some changes. There's been recognition that ZFS on Linux is kind of the primary development environment where a lot of OpenZFS development happens. So it's a great time on one hand to be a ZFS on Linux user. From your perspective as a developer, are there things that kernel maintainers can do to make this harder for you? Do you expect that to happen? Or is it sort of like, yes, there's occasional breakage, we got to figure some things out, but you're not worried?
I've heard suggestions that they can. I have some ideas for ways that they might be able to, but they'd be making a lot of work for themselves to be going after us in that way, because they have to be re-architecting their code in ways that hide things that we need, but do it in ways that I've actually thought about how you would do this. And it would actually make Linux slightly less efficient. So I really don't think there's any appetite for doing that.
I would agree with that. I mean, I'm not an OpenZFS developer, but the developer whose comments on the LKML really got this whole thing kickstarted was Greg KH. And I don't think that his tone was particularly professional. He was a little peevish, but I think there's a huge difference between being a little bit peevish about a non-GPL kernel module and actively trying to sabotage somebody else's code. And I do not believe there are any senior Linux kernel developers who would indulge in that kind of thing. I don't think anybody's coming after ZFS.
I wasn't that upset about what Greg said. He's basically Linux's #1 fan. If something's not in mainline, he's not a huge fan of it, and it's not just ZFS in particular that he's picking a bone with. It's basically anything that's not in the main tree. And he's also a huge GPL fan, where he's like, he just doesn't really want to spend any of his mental cycles on anything that's not GPL licensed. So I wasn't really surprised by his remark, and I wasn't particularly offended, as Greg and I know each other. We've collaborated slightly on a few things in the past, and he's not a bad guy. He's just he's Linux's #1 fan. I'll just put it that way.
I think we're just very grateful for your insights here, Richard. Thank you for joining us. Where can they find out more about you, or find you on social media?
I'm not actually on social media unless you go to GitHub. I've always been somewhat concerned that people would use social media for bad things. And I just never went on it, as it just didn't make sense to me. I was like, why would you open yourself up to that risk?
I think you've been proven that that's pretty reasonable in these days and this day and age.
Yeah, I was surprised it took so long. I actually had trouble understanding it at first, so I asked a friend of mine what the point of it was. And what he told me was that it was a way to ensure that home burglaries are much more convenient for all parties. The homeowners don't have the unpleasant experience of being burglarized while they're there. The burglars don't have the unpleasant experience of dealing with homeowners when they're there. It just makes the entire affair much more pleasant. And I was like, why do I want to be burglarized in the first place? So I don't really do social media.
Thank you for joining us, and we look forward to seeing more of your great contributions to the ZFS project in the future.
Have a great day.
Thanks again to Richard for joining us today. He really helped clear things up. And you know what? I'm more enthused than ever to go build ever more ZFS file systems. You can, of course, find links to everything we talked about and all the things Richard mentioned today over at techsnap.systems/396. You can also find the backlog of all the episodes of TechSNAP and the ways to get in touch with us. If you want to find all the other fine Jupiter Broadcasting content, well, of course, we've got a YouTube page and jupiterbroadcasting.com. That has everything you want, including the calendar of when we'll be live. It's also got some of our great new shows. Make sure to check out User Error. And if you were a new Linux user, or you know someone who is, don't forget to try Choose Linux. You can find more of me over at Wes Payne on Twitter. And of course, you can find Jim there too.
At JRSSNet.
That's it for this episode of the TechSNAP program.
And we'll see you in a couple of weeks.